Up here on the surface, sunlight drives a biologically rich ecosystem. Plants photosynthesize, herbivores graze, and predators hunt in a world defined by predictable, abundant energy. But if you look closely at this lush limestone cliff face, you'll see a massive entrance leading into an entirely different reality. Leaving that energy behind requires a physical plunge. The temperature drops sharply. You squeeze through tight, wet rock crevices, and within a few dozen feet, you lose all natural light. Once the descent levels out, the sheer scale of the environment becomes clear. Explorers regularly map massive, completely silent chambers containing crystal-clear subterranean rivers and deep, still pools. It is a world of absolute, permanent darkness. Yet navigating these pitch-black waters is a specialized creature. It is translucent. You can see its red gills and internal organs through its skin. Notice the rudimentary, sunken socket where an eye should be. Deep caves are extreme nutrient deserts. Without sunlight, there are no plants or algae to form the base of a food web. Despite this, over 200 species of fish have successfully inhabited these environments worldwide, forcing us to ask what drove them into this abyss in the first place. The answer lies in the climate relict hypothesis. This scientific model suggests that isolated cave populations are the surviving remnants of species that fled ancient, extreme climate shifts. To see how this happened, we have to look back thousands of years to an era of global climate instability. During periods of massive glaciation or severe drought, surface rivers became lethal, either freezing solid or drying up completely. Meanwhile, the subterranean water table remained at a stable temperature. Surface fish that already possessed nocturnal traits like heightened smell and touch sought refuge in these underground waters to survive. Eventually, those severe climate shifts eradicated the populations left on the surface. When those surface fish died off, the connection to the outside world was permanently severed. The surviving fish were locked underground. This permanent isolation turned the cave into a rigorous testing ground for survival. The trapped fish had to adapt to total darkness and minimal food, or perish. The first phase of this change is driven by relaxed selection. This is an evolutionary process where traits that no longer provide a survival advantage are simply abandoned. In a pitch-black environment, producing melanin for camouflage or sun protection is entirely useless. Because there is no penalty for lacking color, mutations in genes like OCA2 are allowed to accumulate. Over generations, the fish lose all pigmentation. The same biological math applies to their eyes. Maintaining visual tissue requires a significant amount of energy. In a starvation environment, spending precious calories on a sensory organ that cannot detect light is a lethal disadvantage. When scientists place a modern cavefish next to a living surface-dwelling relative, the scale of this divergence is obvious. The cavefish has discarded the very features that define its surface-dwelling cousin. Losing sight and color is a calculated energy-saving strategy. In a world of permanent famine, discarding an expensive sensory organ ensures every available calorie goes toward finding a rare meal. But losing traits is only half the story. The fish also undergo intensified selection, an evolutionary process where non-visual survival traits are hyper-enhanced to compensate for the loss of sight. These line drawings show the heads of two cavefish species. Notice the heavy modification of the lateral line system, a network of sensory organs used to detect movement and vibration. In cavefish, this system is massively expanded, featuring prominent raised ridges across the head and body. Within these raised ridges are high densities of neuromast cups. These are tiny sensory receptors that detect microscopic changes in water pressure. This anatomical upgrade allows the blind fish to map its physical environment and track prey with radar-like precision. They pair this sensory array with extreme metabolic upgrades. When rare floods wash organic matter into the cave, the fish binge-eat, storing enough fat to survive up to a full year of starvation. These sensory and metabolic upgrades make these fish remarkably efficient. They are no longer just survivors. They are the primary hunters of the subterranean world. For decades, biologists debated whether caves were simply evolutionary dead ends, places where strange animals went to slowly die out. The evidence suggests the opposite. Caves are biological records of a lost era. However, the fish are perfectly specialized for a perfectly stable environment. That absolute specialization is now their greatest vulnerability. Because food is incredibly scarce, cavefish have a very low population turnover. Some individuals take years to mature and can live up to 30 years in the wild. If a sudden environmental shock occurs, like agricultural runoff or groundwater pollution, the slow breeding population cannot recover. The same isolation that shielded these fish from an ancient climate catastrophe now leaves them critically vulnerable. These highly specialized organisms are fighting for their very existence in the dark waters right beneath our feet.